Okay, yeah, we'll start. So yesterday we were discussing about the Spark component and the Spark working architecture, right? Right, the master program or slave program or driver node or worker node we had discussed, right? With the advantage of the Spark, right? It is not a disk sharing, right? I mean, it will reduce multiple IO operations, right? Multiple IO operations. To overcome multiple IO operations, right? Especially in the distributed processing system, people will prefer the Spark instead of the I mean, MapReduce, right? MapReduce also we have that process engine or compute engine, right? I mean, for distributed data processing for big data analytics, right? For big data analytics, but to overcome that multiple operations, right? From that Spark, we'll use the especially the low level API, right? The low level API or maybe that initial API of that Spark, right? That is called RDD. That is called RDD. So what is the usage of that RDD? Well, yesterday we were discussing again. Let me repeat one more time. Right, see. Yeah, you're able to see my screen, right? The step one, there is this, I mean, the storage, right? Hadoop distributed file system, right? So if you want to read the data, right? For example, maybe you have read the data from your input and now the data is available in Hadoop distributed file system. On top of it, you want to perform some transformation. Each and every transformation, nothing but a one job, right? Each and every transformation, nothing but a job. What your transformation? It will read the data from your storage, from your hard disk, right? I mean, that virtual machine hard disk. Then it will dump the data in the job one nothing but it will dump the data into that in memory. It will perform that operations, right? It will perform that operation again. It will write the data to the storage, right? Yesterday we discussed that we will first implement the sorting. The job of nothing but a kind of your sorting. The I mean from that raw data, it will apply the sorting again. It will write the data to again your Hadoop distributed storage. What next? On top of it, again, I want to generate the sequence number. That is one more job, right? Each and every transformation, one job, right? On top of it, again, I want to do the one more transformation, generate the sequence number. Again, the job two will it will read the data, the sorting output data from your storage. On top of it, it will apply the sequence. I mean, the sequence numbers concept. Then the final. I mean, the calculator output again. It will write the data to the storage. In case we want to perform again one more transformation, right? Again, it will read the data from your storage, the calculated data, right? The sequence output data. Then again, it will load the data into the in memory. On top of it, again, it will apply the transformations. Again, it will write the data to storage. So indirectly, you're increasing your multiple IO operations, right? Multiple IO operations, especially for your data sharing, right? Or a data share because you want to share the data from your hard disk to in memory, right? Each and every operations, right? Each and every operations you're writing the data to storage. Again from the storage you're taking the data into that in memory. Again you're applying the transformations, right? If you have, for example, you want to apply the n number of transformation, n number of times you're writing the data into your storage, n number of times you're loading the data into that in memory. Ultimately you're increasing your multiple IO operations, right? Right. You're increasing too many IO operations, especially the data sharing. Definitely, it will take more time, right? It will take more time. You will see, I mean, performance issues on your entire the distributed processor engine, right? Distributed process engine. To overcome, especially this issue, right? To overcome this issue, right? I mean, people move to the Spark. From the Spark, how can I improvise my performance? How can I improvise my performance? Ultimately, my goal, I want to reduce a number of IO operations, right? A number of IO operations, especially if I'm doing the data sharing, right? If I'm doing the data sharing, if I'm implementing the some calculations or transformations, I want to reduce multiple IO operations. My main goal, right? Only once write from the hard disk. That in between the number of transformation should be apply or should be implemented into the in-memory. But if you go with this mechanism, definitely you will reduce multiple IO operations, right? Any database or any technology, if the database technology is having the more IO operations from the main storage to in memory, right? Definitely you will see the performance issues. To overcome the performance issues, always you have to restrict only one-time read, one-time write into your storage. To overcome this issue, right? To overcome this issue, RDD came into that picture. All right, RDD came into that picture. A resilient distributed data set. See, iterative distributed computing, the processing of data over multiple jobs requires reusing and sharing of data among them. Before RDD came into the picture, the frameworks like Hadoop faced difficulty in processing multiple operations per job. Right, one job means one transformation. Right, also a stable and distributed intermediate data store was needed, like Hadoop distributed file system. But nothing comes for free. Data sharing leads to slow data processing because of multiple IO operations. Right. To overcome these issues, right, to overcome these issues, people preferred especially the Spark. From the Spark, how can I implement this methodology, right? With the help of the especially the low level API, right? The low level API that I mean maybe that initial Spark version of the API is called that RDD, resilient distribution data set. Here RDDs will be taken care because RDDs are lazy evaluation, lazy evaluation because it will your jobs will register the code into the in memory. It will not execute until unless if you execute the actions, then only your jobs will be activated. It will process the data. Once your once your action executed, that action associated transformations are executed, then only the data will then only the operations will be activated. Otherwise this is a kind of skeleton. Like here, use the different functions, right? You use the different functions. See, now everything the job in memory, right? The job to also reading the data from the in memory, right? Final writing the data to in memory. From that in memory also you can take that output, or again you can write the data to your hard disk. It depends on your requirement. Depends on your requirement. Here you will see that less number of IO operations, right? Because here IO operations are happening only in memory, not from your hard disk. Definitely, this is a low latency, right? Not high latency, right? Right. You're reducing your multiple IO operations, especially on your storage. Now, your operations are executed, especially in memory. Your output also you can take from that in memory, or your output also you can write the data to your storage. Depends on your requirement. Right. The resilient distributed data sets are a distributed memory abstraction that helps a programmer to perform in-memory computations on large clusters. That too in a fault tolerance manner. Yesterday we discussed that, right? If something went wrong, one of the worker node was offline, right? Maybe it was crashed, right? It was crashed during the data loading process. Right, immediately your cluster manager will activate, right, the replication factor. Based on the replication factor, it will activate, right, that alternative, the worker node. It will continue the data processing. It will continue the data processing. Right. RDDs are considered to be the backbone of the PySpark, right? Backbone of PySpark or Spark, right? Because here, especially in the Spark or PySpark, each and every operation, the Spark, it will convert into that internal RDD because the fault tolerance. Because to achieve the fault tolerance concept, that is Spark responsibility. You can create RDDs explicitly, but in default, if you're writing any operations, right? If you're writing any APIs, if you're writing any APIs like your data sets or data frames, right? That internally the Spark will convert into that RDDs, the partition RDDs. Yesterday we were discussing it, the partition RDDs, the direct acyclic graph, the physical execution plans, logical execution plans, right? Inbuilt RDDs were what you enter code into the native, right? The native code here, that RDDs. Let's see. The in-memory data sharing makes RDDs 10 to 100 times faster than network and disk sharing. Right. Especially in other distributed processing systems, not only MapReduce, other distributed data processing system, are they're spending too much amount on especially network and disk sharing because they are doing that multiple IO operations. To work on multiple IO operations, again, they need to come up with more networking and disk sharing tools or technologies, right, to overcome the issue, right? I mean, to improve the performance, to improve the performance. But here, everything is it is in memory computations, right? It is very powerful, right? To definitely it will speed up your data processing. Definitely it will speed up your data processing 10 to 100 times faster than your especially network and disk sharing or your map up, I mean map redis operations or maybe other process engine, right? Especially other process engine means the distributed, I mean the distributed data processing framework, right? So here each and every operations, right, it will convert into that here, especially partitions, partitions. But the nature of that RDDs are immutable. Immutable means it will not change. It will not change. If you want to, you can change, right? If you want, you can change, right? On top of it, again, you can give with the same naming convention. But the default that RDDs are immutable. Once you create it, there is no way to change the value. But on top of it, explicitly again, we can redefine the same name, right? It will not change the. I mean, it will not change the state. It's always constant. But you can create a number of RDDs. You can create a number of RDDs. But the definition, the definition of the functionality of the RDDs are immutable. Let's see. The data in RDD is split into chunks based on the key rate. Based on the key, RDDs are highly resilient. They are able to recover quickly from any issues as the same data chunks are replicated across multiple executor nodes. Means your worker nodes, right? Means it depends on your multiple workers. If something went wrong, immediately the data will be copied into another worker node. It will continue the process. If one executor node fails, another will still process the data. This allows you to perform your functional calculations against your data set very quickly, right? The power of multiple nodes. But that is the advantage of the RTD set. Advantage of the Spark or PySpark. Because everything it is a fault tolerance. But maybe other distributed processing systems or compute engine, we don't have this facility, right? We don't have this facility. I mean, immediately you can recover your failures also. I mean, failures, not your program failures, while doing the data processing in your worker node. Once you create RDD, right, it becomes immutable. Right? You know, right, the definition of immutable and mutable. Right? Immutable means it is always constant. Right? But you can transform your RDD from one RDD to another RDD. I mean, you can remodify your RDD also. I mean, the same naming convention you should use. Right? For example, a equal to 10. Right? If I'm trying to modify that value, it will not allow, right? Right? Or s equal to abc, right? If you want to modify a character, right? A character from the string, it will not allow, right? If you're trying to use the subscriptable, right? The slicing value, that index value you're trying to change a to x, it will not allow, right? Because string is a immutable, right? It is a constant, right? If you want to change, again you can go and redefine a equal to xbc, right? Again you can redefine, again you can redefine, again you can retransform your content to the new content, means redefinition, right? Again you're redefining your value. At that time it is possible, right? At that possible, but the direct the data type value we can't change it in the Python, the mutable or immutable. Yes, list is mutable, we can change the I mean we can change the content with the help of the indexing or index number. With the help of that index number we can change, or with the help of that append function, or with the help of the delete function we can modify the content, right? The same way RDDs are immutable. RDDs are immutable. So these are the features of that RDD, right? The step one, it is that in-memory computation. In-memory computation, here each and all the transformations, the jobs, the process, everything will be executed and it will be saved into that in-memory. The second point is the lazy evaluation. The second point is that lazy evaluation. right? If you're performing the transformations, right, you're performing the 10 transformations on your input data, right? Those 10 transformations you are executing that given sequence, right? In the given sequence, one by one you're executing, but each and every but maybe your a number of transformation you're having the proper dependency, you're having the proper dependency, right? You're having the proper dependency like 1 to 10 in the given sequence. 1 to 10 your transformation, right? 0 is your data reading, 11 is your data writing, right? 0 to 11 in between you're performing the 10 transformation between 1 to 10, but the 10 transformations, right, you want to follow the proper sequence, right? First you want to arrange the data. On top of it, maybe you want to perform some aggregations, right? On top of it again you want to generate some sequence numbers. Maybe you want to implement some kind of pivot logics, right? The 10 transformations you have applied, 10 transformations are you have applied, but especially in that RDD, right, that each and every transformation immediately it will not hold the data. It each and every transformation it is similar to your user defined functions. Just you are registering your transformations logic into your in memory, right? While creating the transformations, right, if you're executing a transformation, it will not hold the data. You should complete your all transformation. Once you have executed any action on your transformation, right? Action means, for example, you want to see the data, right? You want to see the data, right? That is one type of action, right? That is action. If you want to execute any action on your transformation means, right, you're defining the 10 transformation, right? Each and every transformation is having the proper dependency between 1 to 10 in the given sequence. If you're executing the 10th transformation, right, the 10th transformation is dependent on ninth transformation output, right? If you're executing any action on the 10th transformation, right, 10th transformation, right, the 10th transformation again it will go and dependent on ninth, 8th, 7th, 6th, it will go to that first, it will go to that first, then it will execute the code in the given sequence. Because here all transformations are lazy evaluation. Until unless if you are explicitly execute your action, then only your transformations will return the data, otherwise it will not return the data. So if it is, I mean, especially from the lazy evaluations, right, 100 percentage you will achieve the dependency between your all the transformation. If any one of the transformation got failed, right, it will not continue the process, it will stop there only, right? The fault tolerance again it will execute into the backend another worker node, then it will continue the process because all that operations are registered into that in memory, right? All that operations are registered into that in memory. The power of Spark also, one of the main feature is the lazy evaluation. Already we discussed, right? Fault tolerance, right? When the recovery is very fast because you're maintaining the replication factor multiple worker nodes, right? One of the worker node failed during the data processing, automatically it will pick the another worker node based on your replication factor. If your all worker nodes are failed, right, if you don't have any alternative worker node, then only your program will fail, right? Otherwise, it will not stop your program. Immutability, right? Immutability. By definition itself, the RDDs are immutable. You can't change that RDD state, but you can transform your RDD state from one RDD to another RDD. The partitioning, right? Dividing the data into n number of tasks, right? Each and every task nothing but one paired RDD. All right. You can distributing the data, right? RDD, the advantage, the definition of the RDD, a resilient distributed data set, right? Means your data you're distributing into multiple worker nodes. Inside the multiple worker nodes, you're executing multiple tasks, right? That is nothing but each and every partition. You're dividing the data into a number of partitions because you want to achieve the especially distributed manner, right? You want to achieve the distributed, right? If you want to distribute the data means the data should be distributed into across the multiple partitions. The advantage of the Spark, right? The partitioning concept, the persistency, right? Because everything the data is available into the in memory, right? Because even RDD also inbuilt, it is using the coerce grain operations. There are two types of operations we'll discuss, all right? So these are the advantage of the RDDs. These are the we have that one more fine grained operations and coarse grained operations, whether it is full or partial. All right, your atomicity, So these are the different types of features of that RDDs. All right, we'll discuss one by one. Already we will discuss it in memory computation. Right? It improves the performance by an order of magnitude. Right? The concept of the in-memory computation takes the data processing to a faster and efficient stage. But definitely, it will give the good performance, right? Because you're reducing multiple IO operation, to the disk sharing, right? The disk sharing, that networking, right? These things we can reduce, right? Because everything into that in memory. No need to travel from every time your main storage, right? Means here from your hard disk, right? So lazy evaluation threat, it is equivalent to your user defined function. All transformations in RDDs are lazy. Means it does not compute their results right away. For example, I'm building one transformation. For example, sorting off on your input data. Immediately it will not hold the data. Right? For example, I'm applying the some sorting logic. That is my transformation. Immediately, if you're executing your transformation, it will not hold the data. It is equivalent to your user defined function. Right? It is equivalent to your user defined function. Once you have executed any action on associated your transformation, then only it will return the data, then only it will contain the data. Right? Here, the term lazy evaluation says the transformations are applied to the data in RDD, but that output is not generated. So instead, the applied transformations are logged into the in memory. Right? This is one of the advantage of the RDD. Right? We discussed already fault tolerant and immutability. Right? Audits track data lineage information to rebuild lost data automatically, because everything it will be converted into the your diagram data as a click graph, right? Your all your physical execution, logical executions, right? From your main code, it will be converted into the physical execution, logical execution. Then only it will submit the code to the especially worker node with the help of the cluster manager or resource manager, right? If there is a loss of data, the system can roll back to its original state by using the logged transformation. What are the transformations are logged, right? From there, it will take the data, because everything it is a in-memory computations, right? Or data can be created or retrieved anytime once defined. Its value cannot be changed because it is a immutability, right? It is a immutability. Right? The partition thing, but is a kind of your parallelism, right? Your It is a fundamental unit of the parallelism in SpicePark RTD. Because if you want to implement your distributed processing system, here Spark will use the backend, the partitioning concept, right? Partitioning concept, right? You can increase the number of partitions, right, to distribute your data, or you can decrease, depends on your requirement. So sometimes if you're increasing the mode partitions also, it will lead to your performance issues, right? For example, you're doing the joins, right? You're doing the joins between A and B tables, A and B tables. For example, from that A, you're dividing the data into the 100 partitions, just as them. Your B data is available in the 50 partitions, right? But if you want to implement the joins, right, your 100 partitions data, right, should compare with all the 50 partitions, but your data volume is very minimal, not huge amount of data. Unnecessarily, your shuffling and your time travel will take more time, right? Because each and every partition, it will go and scan after each and every partition of the year. B table, A table contains 100 partitions, B object contains 50 partitions, but your data volume is very minimal. So in this case, we should not increase the partitions, right? In case your default, if it is equivalent to 100, equivalent to 50 based on your data, right? Based on your data, right? If it is possible, we should decrease your number of partitions, because you're clear, right? The B table is contains how many records, right? What kind of nature of the table? Is it every day we are updating? Every day we are generating more amount of data. You're 100% sure about your data length. Yes, the data length is very minimal, but I want to do the joins. Right? I want to do the join. Then we can decrease the number of partition. If the data volume is very high, right? So which transformation requires more partitions, which transformation required less partition, then we should understand, then we should decrease that partition. If required, we'll increase. If not required, we'll decrease the number of partitions. Each and every partition nothing but one type of block, right? Right, the results RDDs are always reusable. Users can reuse the PySpark RDDs and choose the storage strategy for them. Right, always, because the data, everything is available into that in memory. Right, here we are applying the coarse grain operations with the help of the transformation like map, filter, or group by operations. Right, the coarse grain mean right, one is an operation applied on an entire data set. We have the two types of especially performance tunings, fine grained and coarse grained, right? Especially the fine grained, it will apply the your transformation on each and every smaller set. But here the coarse grained, right, entire data set you will apply, like here map, filter, or group by operations. So the map means each and every row I want to apply my logic, right? Each and every row I want to apply the logic. Why should I apply each and every row? Let me apply that to my entire row set. Right, but your fine grained up transaction depends on your transformation, depends on your transformation. If you're selecting the right transformation, that operations I want to open and enter data set, that is called coarse grained. Now I want to apply the transformation, the nature of the transformation, right? I want to take that transformation each and every row, that is called fine grained transaction. These are inbuilt. No, I mean, we are not explicitly defining what is coarse grained, what is the fine grained. Right, depends on your transformation. It will apply the coarse grained concept or fine grained concept based on your transformations, based on your transformations. But how can I create that RDD? Right? How can I create that? This 100% interview question. How can I create that RDD? Interview, they will ask the questions how to create that RDD. Right? There are three ways to create that RDDs. There are three ways to create RDD. The step one, you can read the data from your any external data set, or maybe your data is available in abc.txt. Right? If you want to read the data from the abc.txt, right, you want to perform some transformations on your abc.txt, you want to do some data processing, right? But right, from your external data set also we can create that RDD. No, I don't have that external data set, I don't have that file. But what is that alternative? From your collections, from your collections means your list, tuple, right? These are the collections, right? Right, if you want to create the RDD, your range, right? Range, set of sequence number, right? I want to create a RDD based on my range function. The range is nothing but one collection, right? From that collection objects also, you can create your RDD. The third one, right? We can transform your RDD to another RDD, right? I mean, the calculated output. Now, I have done the sorting. On top of it, I want to generate the sequence number, right? Or vice versa, right? Because your second RDD is created based on your first RDD, right? Maybe your first RDD, right? Creating from the text file or from the collection, right? It contains only the data which is maybe in the proper sorting. The second step, you want to generate the sequence number. Where can I generate the sequence number? You want to generate the sequence number again from the text file. No, why should I read the data from the text file? Already data read by your RDD1. Now it's the data in the proper sorting, right? Now RDD should be created based on your RDD1, right? By performing transformation on that existing RDDs, right? So there are three ways to create your RDD. There are three ways, three methodologies we can use to create your RDD. The step one, from data set text file. The second is collection. The third is from another RDD. Okay, yeah. What are the steps? There are three ways, right? There are three ways to create your RDD. The first one, creating RDD from the collection. Right? Creating RDD from the collection. What is your collection? Your list is your collection, right? List is your collection. List is your collection. Right? Like, let me use ADB. This is your list, right? This is your list. Right? I want to create my RDD. I want to distribute the data from this list. Distributed data from this list, right? Distributed data from this list, right? We have the Spark context, right? Right. So there is some parallelize function, right? There is some parallelize function. Let me go and create here L. Let me create RDD underscore one. Now, right? This is Spark context. Spark context, which is that initial entry of your driver program or your master program or your main memory, right? Or your main node, right? From that main node, the Spark context, it is equivalent to your kind of your database connection, right? Database connection. The Spark context, it will take the request from your user, that user submitting the request list, right? The collection he wants to execute. This entire code, it will convert it into the special physical execution, logical execution tag. Then it will submit the request to worker node with the help of the cluster manager or resource manager, right? Now, what is the use of from your Spark context? From your Spark context, we have one methodology, parallelize methodology. With the help of the parallelize methodology, right? With the help of the parallelize methodology, we can create that RDD from your collection. So this is syntax. So this is syntax of to creating the RDD from the collection. The Spark context dot parallelize. With the help of the parallelize methodology, we can create that RDD. We can create that RDD. Right? For example, let me see the type of RDD underscore one. Now we are using the Python programming language, right? See, PySpark dot RDD dot RDD. PySpark dot RDD dot RDD. So this is the type of your RDD. This is your type of your RDD. Let me use RDD underscore one. Let me execute. Are you able to see the data? No, right? See, parallel collection RDD of 0 at read RDD from input stream at Python RDD dot some scale of 413. You're not able to see the data, right? You're not able to see the data. If I'm executing that L, I'm able to see the data, right? Because this is a list, right? Now this is that RDD. This is that RDD. You have created RDD. But if you want to see the data, right? If you want to see the data, right? If you want to see the data, you have to execute one action. You have to execute one action. RDD underscore one dot RDD underscore one dot collect. The collect function is used to collect your RDD's data or collect your data frame data from main memory, right? From the main memory. Once you're using the collect function, right, that entire the data, it will be loaded into that main memory, means from the master node, from the master node, from the master node only that output will extract. That output will extract. Don't use collect function, especially on your main data. Right here, I'm executing because the small amount of data, right? Small amount of data. Right, see, now you're able to see the data, right? Now you're able to see the data ADB, ADF, your logic app, because you have executed some collect function. You have executed collect function. You want to collect the data from this RDD. If you're executing the collect function, right? Execute collect function on your RDD, on your any data frame, right? That enter data will be loaded into your master node or main node or driver node. From the driver node, it will display that output. Don't entertain any collect function, especially on your data file. You can use the collect function should be very minimal, right? The data should be very minimal. The data should be minimal. So collect is an action. Collect is an action. With the help of the collection, you can collect the data from your Spark API. Here your Spark API is RDD underscore one. If you want to see the data from your RDD underscore one, right? Now here you have executed it in the Python, right? In the Python, if you want to see that output, will use the RDD, I mean your object name, or you will use the print statement, right? If you want to see the data, right? The same, right? Now I'm not able to see that output because this is a lazy evaluation. Right? This is once you have executed your output, once you have executed your output, sorry, I mean action, then only your transformations will contain the data at this stage. Again, let me go and execute. Same thing, right? If you execute the collect function only, at that time only it will contain the data because it is a lazy evaluation. If you want to see the data from your transformation, you have to use that action. Then only you will see the data. Otherwise, you don't have any options to see the data from your RDD. Your RDD. Alright, most will frequently use the collect function in the real time, not on your main data. Maybe your columns, maybe your data structure, your data types, right? At that time, maybe we'll use the collect function, but don't execute collect function which data frame or which RDD contains the data. Contains the data, don't apply. I mean, don't execute. Maybe your data, right? Your data frame contains only the column names. Right, your data frame contains only column names. Maybe your data contains, I mean, your data frame already contains only some data types information, right? It's not holding huge amount of data, hardly maybe 100 or maximum 100 or 500 records, right? 500 records. Not, it is not talking about your business data. It is talking about your metadata information, right? At that time, maybe you can use the collect function. Maybe you can use that collect function, but don't execute your collect function on your business data. If you execute collect function on your business data associated RDD or associated data frame, right, then you will see the performance issues because your driver node not contain huge configurations, right? Like your worker node, because your entire operations will be executed on your worker node. That's why people will increase main and worker node. But in your project, you're executing main operations on your driver node, right? Then you should increase your driver configuration. Otherwise, you will encounter the heap memory issues, right? Heap memory issues, memory exceeded issues. I mean, your jobs will fail. Right? You're deals with a huge amount of data. You're collecting the data from your memory, but your memory is not having the sufficient data. Right? Your memory is not having the sufficient data. Definitely, you will encounter the performance issues. Definitely, you will encounter the performance issues. Right? Now you have created RDD. Now you have executed your collect function. Right? Collect function. If you see, go and observe your output again equivalent to list. This is your action. Once you execute action, you will see that output. Right? If you want, you can assign to that one variable. This is interview question. Okay, if I'm executing collect function on my Spark API or PySpark API, API means your RDD or data frame. Right? Let me execute. Let me see the type of it. Let me see the perfect. Let's see list. But if you're executing your collect function on your Spark APIs, right? Or maybe the structured APIs or low level API, if you're executing the collect function, if you're executing collect function on your API, right, that output will be captured into that list. Now this is a list about RDD or data frame. Now the data is available in the list. Right now the data is available in the list. Right on top of it, we can execute our Python programming, right? We can iterate with the help of that for loop, right? Or with the help of that while loop, we can iterate. We can perform all that operations, right? We can perform that all the operations one by one, right? All that operations we can perform one by one, right? Now that output is available in your list, right? Then maybe from this output, I want to perform some calculations, right? I want to iterate, but how can iterate? That's why we are using the collect functions. But don't execute collect function on your business data. On your business, just assume this is not your business data. This is a kind of your lookup data. It contains very minimal data. Maybe this is your metadata information. Definitely your metadata information or minimal, right? This is a always kind of constant information that you want to retrieval. On top of it, you want to execute, right? On top of it, you want to execute. Right? The collect is an action, not transformation. Collect is an action. Right? With the help of the collect function, we can collect the data from driver node. From the driver node, many actions will collect the data from worker node, but collect function will collect the data from the driver node. Okay, the step one, right? The step one, the creation of RDD from your collection, right? Even we could create one more RDD, right? RDD underscore range, RDD underscore range, sc dot parallelize, right? sc parallelize, right? What is your requirement here? I want to create my RDD underscore range from collection, right? Let me use the range function. Let me use the range function. The range of 10 is a collection, right? Range of 10 also collection. It is a iterator, right? Range of 10 also collection, right? Yes, I want to create that RDD. I want to create that RDD. Right now you're already created, right? Your RDD, Python RDD up to at RDD at Python code dot scala code.
This SC also system defined function, huh?
Let's spark. Correct, correct. Inbuilt spark context. That is inbuilt one only. That is it inbuilt. That's why if you observe sc dot tab, right? We haven't created it. These are the all the functions are available in your Spark context. Not only RDD, any other functions also available. Right? Any other functions also available from your Spark context. So these functions are available from your main memory, right? Now I want to see the data, but how can I see the data, right? How can I see the data, all right? How can I see the data? Let me use RDD underscore range dot. So what kind of transformations, what kind of actions are available inside this RDD? Right? So these kind of functions, these kind of validation functions and transformations actions are available. See, collect, right? Collect is a one type of action. Right? You can cache, you can reusable this data. Right? Cache means you can reuse this data. Still the data is available in memory. Again, you can reuse. Whenever you're executing from this memory only, it will take. Right? You can execute the Cartesian product also. You can execute your Cartesian product. That's kind of your join that Cartesian product, right? Cross join. Right? You can use the distinct. Right? You can use the filter function. So these are the different type of transformations, actions. See the first function, right? Right. What is the data from that first zero value, right? First also it is a action. First also it is an action. If you want to see the data, if you want to see the data from your RDD, right? Your RDD contains a number of values. No, I want to extract only the first value. I want to extract only the first value. Then we'll use the first action. Then we'll use the first action. Right? There are different types of transformations. Transformations are available. Transformations actions. Other validation functions are available in here. RDD. See count function. Right. If you want to do the count, right? Count equal to your 10 value, right? Count equal to 10 value. Alright, if you want, you can assign the function c equal to f equal to. Then check the data type. Check the data type because you are applying some action on your transformation. So this is belongs to which data type? Right? This belongs to which data type? Type of f integer, right? It is belongs to integer, right? It is belongs to integer. From this integer value, right? From maybe in your output file, maybe your input file, from maybe your collection, right? You want to check the first value belongs to. some 0 or 1. If it is 0, I want to execute some calculation. 1 is I want to execute some calculations, right? Then we'll use the especially the first function because the based on the data it is giving, right? In case if you are providing the text data, right? If you're providing the text data, the data type is equivalent to string, right? Because the first value is from the range 0 1, right? 0 1 2 3 4 till 9, right? So that's why your first value is equivalent to integer. If you're executing the same logic, right? If you're executing the same logic from above RDD, right? Now what is it above RDD? RDD underscore 1, right? No, you're able to see that instead of because the data is right, the data is the string, right? ADB is the string data type. That's why you're able to see the str because your first is not equivalent to integer function or not equivalent to your string data type. It is based on your data, right? Because it will retrieval the first value from your RDD. That value, right? That value, if it is integer, your F1 data type is equal to integer. If it is string, it is equal to string. If it is decimal, decimal. If it is a none, none. Boolean. Your first function only it will retrieve the first value from your RDD. It is equivalent to your where row num less than 2 function, right? Where row num less than 2 function, or maybe in that Python, right? Python maybe you're using the zero index, right? Zero index. L of 0, right? L of 0, 0 index, right? L of 0, it will display the first value, right? From that RDD, if I want to extract the first value, we'll use the first action. We'll use that first action, right? Right, the same again, we'll execute the same logic for the count. What is the count function? Count also it is an action. Count also it is an action, not transformation. The count for count will use very frequently in the real time. The count function also available in the data frame. Even the collect function also available in the data frame. What is the usage of the count function? The count function is used to count the number of elements from your API. Here your API is RDD, right? From this RDD underscore range, right? From RDD underscore range, right? How many values are available? I want to count the number of values. I want to count the number of values from this RDD underscore range. From this RDD underscore range, then we'll use the count function. Then we'll use the count function. It will count the number of elements. The number of elements from your RDD. 100% the data type is equivalent to integer only, right? Because it is counting agree kind of your aggregator functions, right? Kind of your aggregator functions. It definitely it will give that only the number, right? It will count the number of elements from your RDD underscore range, right? Clear, right? We'll see one more or range, right? Or same, it is equivalent to your SQL operations, right? Select count of star from table. There we are using the select statement from table count function, right? In the database point of view, we should follow the database syntax, right? Here we should follow the especially the Spark syntax with the Python programming language, because here we are defining the Python programming language. If you want to define the same thing, the scalar, then we should define either val or var, right? Val or var. We should define tab. We'll see the other actions, count action. That you can use the sum function. Correct. If you want to perform that aggregate function on your RDD, correct, you can use the sum function also. You can use the sum function RDD underscore range dot. We don't have. Right, we have the take function also available. Take four values. If you want to extract, right, if you want to extract some four values from your RDD, right? From your RDD, we can use the take function. The first function, it will extract only the first data, right? It will extract only the first data. Let me use the take of one. Right? See, the result set, right? The result set is equivalent to your list. I mean, you should understand each and every API output, right? API output. If you're executing that API output action, the result set is equivalent to integer, or result set equivalent to list, or tuple, or dictionary. All right, you should understand, because this is important, right? From this output, right? From this output, if you want to take it forward into the next calculation, right? From this your action, you want to take it forward into the next calculation. You should understand the data type, right? If it is a list, right? But how, from that list, how can we iterate, right? How can we iterate? If it is a tuple, how can we iterate? But how can we perform the tuple operation? Then at the time, the Python will help out. Now, these are your, especially the PySpark functions or Spark functions, right? Spark functions, but you're executing. Now you have written this logic inside the Python code, right? If you're executing this dot take of 4, right? The result set is equivalent to, the result set is equivalent to which data type? Right? The result set is equivalent to which data type, right? From that output, right? From the data type, then you can do that your iteration, right? You can do that iteration. You can do that iteration. Clear, right? So the take function is used to collect the data from your RDD. From your RDD, the result set is equivalent to list. The first function, it will take that only the first value from your RDD, the result value based on your data. The collect function is used to collect the data from RDD. The result set is equivalent to list. The result set is equivalent to list. The sum function, the count function, right, related to the your integer. Related to the your integer. Related to the your integer. Clear, right? Any doubts? How to create the RDD from the collection? Yeah. To create, but this is 100% interview question. Interview will ask, tell me the methods to create that RDD. All right. There are three ways, right? The first method is collection. All right. They will ask the question, okay, from the collection. So which methodology will use? The parallelize, right? To create RDD from a collection, use the sc.parallelize and pass the collection. The collection, it could be a range, it could be tuple, it could be list. When Spark parallelize method is applied to a group of elements, a new distributed data set is created. The new distributed data set is your RDD, right? This data set is an RDD. One simple method is by parallelizing an existing collection in the driver program by passing it to the Spark context parallelize method. Because this method is available in your AC, right? Right. Because you're submitting this request. Now it will convert the data into the DAG, then it will submit the data to your worker node with the help of the cluster, right? With the help of the cluster manager or resource manager. Right? Parallel collections are created by calling Spark context, the parallel method. Right? The elements of the collection are copied to from distributed dataset that can be operated on in parallel. That can be operated on in parallel. Only that interview question, how you'll create the RDT from the collection. The methodology is parallelized. This methodology is available in Spark context. SC nothing but it is a Spark context. Clear, right? The second is I want to create the especially RDD from the text file, right? Now, why should I use that collection? The collection again, it is a manual activity, right? Now the data is available in that file. The data is available in that file, right? The data is available in that file. But how can I create my RDD? How can I create my RDD? Right, before creating the RDD, right, so I will explain one important command. Maybe this command will use frequently in the real time. Right, RDD underscore range dot get num partitions. Get num partitions. Okay. If you want to see the year RDD is having created how many partitions, based on the data, it will create the partitions, right? So backend, it's created the 8 partition. Means your data distributed into 8 partitions. Your data distributed into 8 partitions. So this 100% interview question, because that get num partition function is not available in the data frame. The get num partition function is not available in the data frame. From the data frame, right, you have created one data frame, right? Like the same way how we created the RDD, right? We'll use the data frame syntax. That you have created your data frame. You have executed a code, but it is taking too much process. Then you realized maybe the backend of the data frame is not having the sufficient partitions. But if you want to do that, especially performance tuning, right? Because your data volume is very high. What is the first step? We should check your data is put into the number of partitions, right? But how can I check your data frame is having the XYZ partitions, but your data frame is not having any get num partition functions? At the time, you should convert your data frame into RDD, then we'll use the get num partitions. That is 100% interview question. Interview, they will ask from the data frame, I want to get the partition number. How you will check this data frame contains how many partitions? At the time, you should convert your data frame dot RDD dot get num partition. RDD dot get num partitions. With the help of the get num partitions, we can check here API is having how many partitions. API is having how many partitions. Okay, let me go and create one dummy file. Let me go and create one dummy file. Already we have. Let already creation from file test, right? So this is your data. For example, let me use dbutils.fs.head command. Let me see the content, right? Let me see the content. Right, this is your ID name salary, right? 101 A 500, 102 B 200. This is your carriage rated slash R means your carriage rated slash N means your new line, right? Carriage written place line feed, right? Line feed. But how can I create my RDD? How can I create my RDD? Let me use SC dot. Right. Let me use SC dot. T. Right. So there is a text file, right? There is a text file. Text file methodology, right? Text file methodology. Right. If you want to create the data, right? If you want to create the data from the text file, all right, we'll use the especially Spark context dot text file. That is a case sensitive. Commands are case sensitive, right? The commands are case sensitive, right? Only that F is a capital. The rest of the are lowercase letters. SC dot. Right? These are the methods, right? These are the methods are available, right? From your Spark context means your driver program, right? driver program. You can see the version, right? You can see that version. Yeah. 3.1.0 because your Spark version, right? This is your Spark version. Right. You can see there is a empty RDD also available, right? From I mean this is an interview question. We'll discuss. Right? There is a get config, right? Configuration details. Let's see. Spark configuration, right? Available at this point. But these are the different types of functions are available. Different types of functions are available in your Spark context. Spark context. Okay, now we have created, right? We have created ac.text file, the file store tables dot slash rdd text file dot txt, right? Now you're creating your RDD, right? RDD from file, RDD from the file. Let me go and execute. All right. Now let me see the data from file, right? From the file, right? Select function, right? Now the data is available in the list, right? ID comma name comma salary, 101 A 500, 102 B 200, right? 102 B 200. Right? ID name salary 101 A 500 to 102 B 200. Right? If you want to get the value RDD from file dot first function, that ID name salary, right? ID name salary. If you want to extract that value, right? If you want to extract that value, take off to that ID name salary 101 A 500. But if you want to see the count, right? Count. You want to see the count. Right? There are three rows are available, including your column heading, right? Column heading, including your column heading. Right? Let me create one more dummy file, text file. But again, I'm entering it, it will go to the new line, right? Let me upload the data. Underscore 100. Underscore one. Let me see the content. Dot collect. So what it will do, it will collect the data from this file, then it will create the list, right? See the first value, right? The first value is belongs to this enter data. That hi, welcome to Databricks. This is your first value. So this is your second value, right? This is your second element. This is your but this is unstructured data, right? But this is unstructured data, right? From unstructured data also we can create that RDD. That not only structured data, because nowhere we have given this is a structure or unstructured. This is a file, right? This is a file. From that file, if it is having the new lines, it will go to the next element, right? It will go to the next element. Right. For example, in this program, they will ask you the question, okay, I have this data, right? I have this data, right? I have this data. I want to retrieve the data. I want to retrieve the data, but I want to create, right? I want to create 101 is belongs to ID, A belongs to name, salary belongs to 500. Salary is belongs to 500. But I want to display the data like this. I want to display the data like this. Right. Now, if you're executing your collect function, right, you're executing the collect function, all right, it display all the values, right? ID, name, salary, 101A, 500, right? 101A, 500. But how can I extract 101A separate, A separate, or 500 separate? Right? How can I extract 101A? Now the data is available in list, right? The data is available in the list, right? Now the data is available in the list. Right? I can use some for loop, right? I can use it for data file content. Okay, file content. Now your file content is equivalent to list, right? File CV int ID comma name comma salary. But I want to display ID equivalent to 101, name equivalent to A, sal equivalent to 500, right? Sal equivalent to 500. I don't want to display ID name salary, but I don't want to display ID name salary. Then we can use that if 120 500, 102 be 200. But you want to see ID mapped to 102 in the display point of I'm talking about. Not I'm not storing the data. Alright, I want to capture this ID 101, ID 102, name A, name B, 500 salary 500, 200 salary. Now the data, right, the combination of three values, right, a combination of three values. So can't we use the split function? We can use the split function, right? Right, we can use the split function, right? If we are using the split function again, you can apply in, I mean, you can extract individual element, right? The earlier data was not into the list. It is a combination of only the single element, right? 101 comma A comma 500. But what is the requirement? I want to extract 101 separate, A separate, 500 separate, right? 500 separate. Now we can use this logic, right, for J in I. Right? Now we can use, right, print 101A 500, 102B 200, 101A 500, 102B 200. We can use it. Okay. In case you may get these kind of questions in the interview, that they will ask, okay, this is my data. I want to extract that all the values separately, right? Then we can use this program. Now, your I.split contains again your list data, right? Again your list data. Again your list data. From this list, if you want to extract one by one, you can see it. If you want to extract, you can extract that values one by one. Clear, right? I mean, these are your Python programming, right? Because these methodologies are very, very important. Just understand that output of your RDD, right? Output of RDD, then you can take it forward into the next level with the help of the Python programming. Python programming. Here you will use the collect function, you will use the for loop, if condition, one more for loop. These kind of functions you will use very frequently. Okay. See, now this is unstructured data, right? This is unstructured data, or any type of data. There is no specific structure, unstructured, right? Even the previous example also, still it is structured, but we are not able to, I mean, split the data based on the specific delimiter, right? Specific delimiter we are unable to create, right? We are unable to create, right? Because it is unstructured data, right? It is unstructured data because you're displaying the data not in the proper structured manner, right? It is displaying that all the record because you're using the collect functions based on the new line characters. It will create into the next element, right? If you're not entering, right, that enter data will be created into that only the single element. If you're exit the collect function also, still it will create only one element because you're not including any new line character, right? If you're entering the new line, that next row it will go to the next line, right? Means in case if you have that any requirement to read the data from the unstructured file, you want to perform some transformations, right? We'll create that RDDs. We'll create that RDD to read the data from your unstructured file, right? Unstructured file, right? You have the requirement on top of it. You want to perform the calculations, right? You want to perform the calculations, right? Then you can use the RDD related transformations, RDD related actions you can use. Right? To create a file-based RDD, you can use the command spark.context to text file or sc.text file and pass one or more file names. Let's see. In this example, I have created one file. I have created multiple files. I have created two files also. Let me execute one by one. Right. RDD. Let me use start.txt. Let me use start.txt. Right. Multiple files. Right. Let me see the data. Let me see the data. Right. See, ID name salary. All right. From one file, this second file. Right. I mean, you can create a RDD from multiple files. I mean, you can use the wildcard character, right? You can use the wildcard star is the wildcard character, right? If you want to extract multiple files, right? You want to extract the multiple files. You have the pattern, right? The pattern RDD test star.txt. Go and see how many files are available. Only two files. Right? Only the two files we are using the start.txt. Right. Only the two files are available. The two files content will be displayed on your screen, right? Because I'm using the start.txt. You can create RDD from the single file, or you can create the RDD from multiple files, or you can mention the two file names also, right? For example, right? You don't want to extract that all the files, right? You don't want to extract that all the files. That maybe you want to extract only the two files RDD test. Right. This is your first file. Right now you have created two files, right? You have created the two files. Let me see the content. Let me see the content. Right. So this is one of the advantage, right? I mean, you can explicitly mention your file names also. You can explicitly mention your file names. For example, I don't want to go with wildcard because from the RDD test there are multiple files. Multiple files I don't want to process. I want to process only two files. Then you can explicitly mention two files or three files or four files. Depends on your requirement. Depends on your requirement. Then go and check your get them partitions. Right? Get them partitions. Right? Three partitions are available on this file. Right? Three partitions are available from this RDD. Right? Let me use underscore multi-rate. Three partitions are available. Clear, right? How to create that RDD from the text file. Right? You can create the single file, you can create wildcard characters, or you can define a number of files. You can define a number. Right? So this is the third methodology. Yes, we can create a RDD from another RDD. Right? You can create a RDD from another RDD also. And we can create. Okay, the third methodology, right? The third methodology, create RDD from another RDD. Create from RDD from means from the select another selector, right? From the select another selector. Maybe you're extracting some data from the select statement. On top of it, you want to perform that another calculations, right? That is nothing but a RDD from another RDD, right? RDD from another RDD. For example, data equal to sc dot value range. Now you're creating an RDD, right? You're creating an RDD. What is the requirement? From this RDD, maybe I want to add that value plus 2 or multiplication 2 on especially on this data points. On especially on this data points, I want to apply the calculations, right? I want to apply the calculations, right? I want to apply the calculations, right? Each and every row, I want to apply the calculations. Right, each and every row I want to up that means coherent operations, right? Coherent operations, right? Coherent operations. See, here if you're using that map, right, it is expecting some function, it is expecting some function, then it is expecting your return values, right? It is expecting your return values, right? Comma u, right? Your return values means I want to call out one function, but how can I call out one function, right? That is called lambda. So lambda nothing but you're calling, right, one more anonymous function. Right, you're calling one more anonymous function. Right, you're calling one more anonymous function from this lambda. Alright. So basically you're calling one function. What is your just you're extracting this x value from this data, then you're multiplying with 2. So the map function, right, the map function or transformation is used to apply the calculation for each and every row. Each and every row you want to apply the your calculation. Now this is one more RDD, right? Data, so RDD underscore map. This is RDD underscore data. RDD underscore data. The first RDD is used to create the values, right? To create the values from the range function. Now you have created the RDD. The second one, right? The second one from the first RDD, right? From the first RDD, I want to apply this logic. I want to apply this logic. X multiply to X multiply to. I want to apply the logic. I want to apply the logic. Now both are two RDDs, right? Both are two RDDs. Let me execute. Right? Let me see the type. Alright, so both are RDD pipe and RDD, RDD here, pipe and RDD. Alright, so what in case we want to see the data, right? Because this is again map also transformation, right? Map also transformation, not action, right? Map also transformation. Now you're not able to see the data, right? You're not able to see the data, right? RDD underscore data. Again, not able to see the data, right? So these are transformations, right? Lazy evaluation, right? Lazy evaluation. Right. The Python are at this scalar dot 58, right? Scalar dot 58. So this is 26, this is your 27. If you want to see the data, right? If you want to see the data, then explicitly we should execute a collect function, right? Explicitly we have to execute collect function. Explicitly we have to execute your collect function. Now this collect function executed on top of it here second RDD. This collection function I'm executing on top of it my first RDD. The both output is different, right? This especially RDD created based on your RDD underscore data. RDD underscore data. Right. If you are executing the collect function, the collect function you are executing RDD underscore map. But RDD map is dependent on RDD underscore data. Then it will call RDD underscore data. Please provide the data. Then it will check, okay, do we have any dependency? No, I don't have any dependency. Directly I have created the especially RDD map from collection. Then it will provide that output. It will generate the data. It will send the data to RDD map. Then that map will send the data to your collect function. Because all are your lazy evaluations. All are your if you have different any transformation you're executing, right, you will not see the data because those are lazy evaluation. If you want to see the data from your RDD, explicitly we have to execute the collection function. So this third methodology, right? This third methodology is creating the RDD from another RDD. Let RDD from another RDD. Clear, right?
Clear.
Any doubts? One or more RDDs can be created by performing the transformation on the existing RDDs and correct. The below figure shows how a map function can be used to create an RDD. That map is a transformation, not action. Map also transformation to create another. Basically here, right? If you want to perform the each and every row transformation, right? We'll use that map function. If you're from the informatica background, it is equivalent to your expression transformation, like your passive. Right? Each and every row, I want to apply the transformations, right? Without, you're not applying that anywhere condition, right? If you want to apply that all the rows, right? All the rows you want to apply the calculations, then we'll prefer that map function. Then we'll prefer that map function. The collect is a action, right? Collect is an action to collect the data from your RDD from your driver program. See RDD underscore X, RDD underscore X, right? Just case sensitive, right? RDD underscore X, RDD dot collect. This RDD underscore X will collect the data from this collection. This RDD will get that output from this function. Lambda is an anonymous function, right? Especially inside the map, we should call out one function, right? That's why I'm using the lambda is a function, anonymous function. This x, right? This x will retrieve the data from your RDD underscore, mean your RDD underscore x, that one by one value, it will read, it will perform the calculations, then it will assign to the your RDD, your RDD. Any doubts?
So the data is generated and stored in the memory only after we execute a task, right?
Correct. The action, right? You're talking about.
Yeah, the action, yeah.
It's correct. Otherwise, same like use a different function, Kiran. Like same use a different functions also, it will not, I mean, activate, right? Until unless you explicitly call out, right?
Right, yeah, yeah.
So this is advantage, right? Whenever you need, you can go and execute, right?
And how long does it stay there? I mean, do we need to clean up or?
No, right? I mean,
Oh,
automatically once your cluster terminate, right? Automatically it will clean up,
okay,
right? It will flush out, right?
got it. Okay.
Based on your cluster, I mean, your cluster is active, right? Your in memory is active. Once you clear shut down, right? It will clean up all the in memory transformations.
Okay, okay.
This is a 100% interview question, right? These three steps they will ask. Yeah, if you don't have any,
Sumant, 1 second.
yeah,
So in this second, I mean, creating RDD from RDD, even though we use map function, at that point of time, the map RDD won't be created, right? Only while using collect, it will be activated.
correct.
So in the same way, when you create RDD from a local file,
Mm-hmm.
so will it be created during the assignment or only after action?
Only action. In
Okay,
memory.
so even though we pass a file pass something like that, it won't be created just like that. Either you need to use collect or something, only then the data will be read from the file.
Correct. You're right.
Okay,
You're right. That's why these are lazy evaluations.
okay.
I have one more question, Suman. So let's say that there's a file X that we ran this task, and there is we updated that file again, and we are running in the same session. We are running the function again, right? So does it like replace at the back end, or it's like in the memory, or is it like it will create like a new block?
I mean, you have updated the data into your hard disk, right?
Yeah.
Already you read, right? Already you read. It is already registered, right? Already it's registered, right?
Okay.
How many RDDs we create? Mean estimation.
Then depends on your like this is your transfer, like BODS depends on your requirement in number of transformations you can include, right? But I mean, the best practice is, right? For example, you're creating, forget about RDD, any APIs, right? For example, you're having the 20 transformations you want to create. Don't go with the 20 transformation in the last use that action. Possible after two, after three, or after five, use one action.
Okay.
Generating too much DAG, right?
Okay, depends upon the transformation, how we
No,
uh,
use one action,
calculations.
right? As soon as possible, you can use an action if possible. In your requirement, if possible, just you can include one action.
Okay.
Yeah, if you don't have any doubts, we'll collect tomorrow. The rest of the slides we'll discuss. I mean, other transformations, actions, we'll discuss tomorrow. Okay, I will share this PPT. Just you can go through. But mostly will not write RDDs in the real time. We'll write only the data frame, but you'll get interview questions. 5 to 10 percentage, maybe you may create RDD like get num partitions, Maybe your requirement is demanding you have to create that RDD. Maybe unstructured data, but your requirement you want to go with the RDD, right? Because this older version, right? RDDs are not older version, not the latest one, right? Older version. but you don't have that option. At that time only, go and create RDD. If you have that option, that your requirement you can fulfill from the data frame, please go and select the data frame. Don't select the RDD. Because again, you're using the low level APIs. Again, it will convert into the low level APIs 2 times, right? But yes, your requirement, like your get num partitions, because I don't have any option, right, to see the number of partitions, right? Then you can convert it to that RDD. You can convert it to that RDD, right? Then you can check. But anyway, will not use the get num partitions in your main code. But in case in your main code also you want to include the get num partitions based on that value, you want to increase your partitions, right? Then you should include data frame dot RDD dot get num partitions. If you have that possibility from the data frame, right, from the data frame, please use the data frame. Don't use RDD in your project. Because these are the low level APIs. Again, your Spark will convert your all that operations into again RDD. You already created RDD, again it will convert into one more RDD. No use, right? Unnecessarily, 2 types of low level APIs calculations. But 99% in your code, you will see that only data frame or Spark SQL. 1% maybe people may use RDD, depends on the requirement, but not in your main code. Okay, not in your main code. We will discuss tomorrow the rest of the topics. Most will finish tomorrow RDDs. Then we'll start the data frame. We'll spend more time on the data frame about requirement, interview questions. Right, we'll discuss in detail because data frame is a lengthy concept. Because we have that more options each and every file level. Also, we have that more options because majority our requirement from the structured data, right? Structured data, right? How to create the predefined structure, how to create the schema. These are interview questions. If it comes to the process, please create the RDDs from the 3 ways. Just execute and observe that output, make a note. Okay, this output is belongs to list. Okay, now we create that RDD. Now that output is available in the list. From the list, what kind of operations we can perform? The regular Python list, right? You can do iterator, right? You can use the for loop, you can use the condition, you can use the while loop. From that output, what kind of operations, right, you're expecting in your requirement, you can fulfill it. Now just you're creating the RDDs. Once the data is available, on top of it, again, you will execute your Python code on. Okay. If you don't have any doubts, we'll close that call. We'll connect tomorrow.
Thank you, sir.
Thank you so much.